big group here joining us tonight. So very, very, very awesome.
Go where?
So in the chat, rate your comfortability. How are you? What's your comfort level for inquiry projects?
Jamie,
And what are you?
I'm admitting a bunch of people, but I
Okay.
did see someone say, I can't remember the
Sure.
person, they can't hear us. Oh, I
They
guess
may have
I'll
to
type
check.
in the chat.
Yeah, I have to check your settings, make sure you have the right microphone, all that. Thank you guys for typing in the chat and check out some of these awesome things that you said. Yeah, a lot of people, they'll have their like output to their smart board, so make sure you change that. Sometimes it'll mess up your settings. Cool. Seen lots of people in the 2, 3, 4s. Some people are new to the grades, so maybe down to 1 or 2. That's fine. Excellent, excellent. Looking for fun projects, engaging projects. Yeah. Very good. Thank you guys for participating. We'll have a couple times during the tiny topic where we'll ask you guys to put some stuff in the chat. Beautiful. Yep, technology is always good. Always fun. So my name's Jamie Height. I'm 4th grade ISD content, sort of like I do the content for 4th grade. I'm an ISD for all grade levels, but my main focus is 4th grade. And then science projects. I really, really enjoy the process, the project process, inquiry process. It's even when I was in the classroom a long time ago, I used the inquiry process as sort of a guide through any type of science I was doing. I always had some sort of inquiry happening in the background. So if I was teaching about weather or something with that, I always had something going along with that. With while we're learning the content, the students were also doing an inquiry project in the background. So it was always kind of a cool thing to do. It always helped with science fair. So I've been doing science fair stuff for many, many years. So my heart is near and dear to anything having to do with inquiry projects, and the whole science fair thing is pretty fun. Last couple of years, I even had the opportunity to judge at the secondary science fair. So seeing what kids are thinking in middle and high school, and some of the things they come up with are just wild. They're really, really, really awesome. But it's a very, very important that they learn these skills in elementary school, K through 5, so they are better equipped when they get to middle and high school. Because I did see some things even last year. I remember there were some gaps in their skills with their inquiry process, things they would leave out or they weren't too sure about. So it kind of made me think like, wow, we need to maybe do a little bit more to give students skills for the inquiry process. Also tonight in the background for, I think, her 3rd tiny topic in a row is our science content specialist elementary, Wendy. Miss
Hello,
Now.
everyone.
Yeah,
I'm happy to be here. I'll be monitoring the chat for Jamie, so
chat and all
glad
that
you
good
all are
stuff.
here. What a great turnout, Jamie.
This is fantastic. Yes, this is fantastic. All right, so we're going to move right into things. Thank you for putting some things in the chat. Saw lots of different comfort levels, so that's awesome. Whether you're a veteran teacher and you've done this many times, or your first year teacher, I hope you get something good out of this. So here's some of the topics we're going to look through. We're going to talk about our overview, Wandering Walls, record keeping, types of projects, formats, things to consider, K-5 projects, resources. We will talk about the showcase a little bit. I want to talk a little bit about what happens at the district showcase and how we can get ready for that good stuff. So on this slide, this is just kind of an overview. We really want to have as many schools as possible to participate in the Science and Engineering Showcase. We'd love to have every school represented in the showcase. In the past, we were close to 100%. I think after our lockdown and things, it kind of went down a little bit. But the showcase has been rebranded. It's a great event. So we really would like to see every school represented in the showcase. I think it's an awesome thing. But as you can see here, by fifth grade, students should have multiple experiences in science inquiry. In the past, I think we focused a lot on experiments, which is totally fine. Experiments is definitely a big chunk of that nature of science because there's lots of elements that are embedded in science experiments. But as we've seen over the years, and even looking at our standards and looking at sample questions from SSA, there's all sorts of different types of investigations that can occur. So we don't want to be pigeonholed in just the experiment process. And believe it or not, they're not tested on like the steps of the scientific method. They don't have to memorize variables and things for the SSA. And what we see on SSA is a lot of like setup experiments. So they might have like a chart or a scenario with an experiment with lots of pictures, like showing what the experiment looks like, or demonstrations. A student might be setting up a demonstration. They have to talk about that demonstration. Field studies as well. I've seen lots of questions about with charts, things they've seen around school, butterflies and birds and all sorts of stuff. Even a little bit of engineering design. So we want to make sure that students have a variety of ways to see inquiry occur in the classrooms. And then just know nature science benchmarks are tested at fifth grade SSA. Anything from 3-5 are fair game, whether they're keeping records or they're sharing tools or sharing data or explaining evidence or talking about repeated trials. Those are all in there. And then a lot of the foundational skills are at primary, so K2, whether they're talking about using their senses, making observations, inferences, those things really occur in the lower grades. So having younger students go through the complex parts of an experiment, they might not be ready for that. I know in the past we've done that, and they're probably not ready. They're just trying to learn what is an observation, how can I keep records and things like that. So we really over the last few years tried to kind of refine some different things here to make sure that there's things that are grade appropriate for students. And then by fifth grade, so this is the big fifth grade N11 benchmark where they're defining a problem. They're doing research for support. They're carrying out scientific investigations. And notice I bolded of various types. So such as systematic observations. So could be some sort of process they're following, but requiring identification of variables. So actually having an independent, dependent variable, collecting data, interpreting charts. That's a big one. Students should be able to graph and interpret graphs and charts and graphics, and also analyze information. They'll get questions on the SSA where they're having to make judgments about different things they see, whether it's a demonstration or a field study or part of an experiment. Or even say, okay, based on this data or based on the data in this chart, which of the following would be a explanation? So are they memorizing steps? No. Are they memorizing, well, the independent variable is this and that? No, they're not. They're not really following all those different steps. So we need to make sure they're getting a variety of different pieces for inquiry. Ultimately, at the end, we want them to be able to put together a display board for our engineering process. And we'll talk a little bit more about that, what that might look like. Schools, I know, will have a school showcase that coincides with our district science and engineering showcase, which is awesome. But not all schools. Not all schools have their own little showcase, but still send projects on over to the district part. And students love to share and talk about what they did. So that's the biggest thing is communication. When I think about nature of science, I always think about communication because students are communicating with each other, which I think is very important that they have those communication skills. So kind of keep that in the back of your mind as we want students to communicate their ideas, share their findings, as we see here, like in some of these pictures. So these are some of the examples of some boards we've had over the years. One thing we want to do is, where do we start? Maybe you're at that point where I don't even know where to start. This would be a great starting point to have some sort of wandering wall or some place where students can add ideas or questions that could ultimately be turned into some sort of inquiry. So if you want them to get these conversations going, you want them to work through. So here's a couple of bullets that you can read here. We want them to, a lot of this to happen during instructions. Sometimes I'm just thinking about one the other day where they were talking about weather and some different things came out of that conversation. The teacher said, well, put it on a sticky note and put it on the wondering wall. So I thought that was a great idea. And they can come circle back. And some of these wondering walls can then turn into an inquiry, possibly. Not all of them, but some of them can. Some of them can. And it's great because it will kind of keep you on pace because I know it's happened many times where students will talk about different things like, oh, let's talk about a hurricane or whatever, but you're talking about air pressure or something. So it might derail. So wondering wall is a great way to put that. Designing an investigation. I love this last bullet. Designing an investigation from a natural wondering versus choosing a testable question from a predetermined question bank supports, encourages authentic learning and discussion. Yeah, we do provide some example questions, but if students are able to derive questions from their experience from the science class, I think they'll own it more. They'll be more into it, more, you know, they'll just be soaked in the learning, and they'll want to put their best foot forward in completing that project. You won't believe how many marbles rolling down a ramp we get, which is fine. It's fine to see marbles rolling down ramps. That's great. It is about the process. Do the students already know the answer to that? So a lot of times, some of these predetermined questions we give you, they already sort of know the answer. So we want them to be excited about it. So that's why we encourage wandering walls. Here's a couple pictures. As you can see, it can be literally on the wall with some chart paper, or it can be just a piece of chart paper, some of that good 3M sticky chart paper for your wonderings. And you can change it out. Maybe change it out per unit. You do some wonderings. I know we're getting ready to move into physical science, which has lots of wonderings when students start talking about matter and light energy, sound energy, all sorts of different things. They're probably going to have all sorts of interesting wonderings. You can put it on a science board and have wonderings there. You can just put it on a little area. You can see just a small area, or you can do a digital one. You see the one in the top right. That's kind of like a digital wondering wall. So real quick in the chat, do you have any ideas? Maybe you have a wondering wall you tried. How did you display your wondering wall, or how do you manage your wondering wall? Or if you have any questions, I'm gonna give you about a minute to put that in the chat. Anybody has any ideas?
Jamie,
I said,
while
this,
people are filling
yeah,
in their thoughts in the chat, I
sure,
just wanted to share something. So I've been visiting lots of schools already,
cool.
and I can't remember what grade or what school this was, but I remember going into a classroom and they had, this teacher had their wondering wall, kept it within the theme, whatever they were
Mm,
teaching. And
yeah,
as I was looking, I'm always taking pictures and reading the wondering walls because I just love what kids come up with.
they're great.
And several of those wonderings really truly connected and aligned with the content that they were teaching. So you
Hmm.
could easily take that sticky note off the wondering wall and address it right then and there. And then maybe choose others. Others, it was great wonderings, but I don't know if it would turn into like an authentic investigation.
Yep,
But then you could say, maybe put this one aside. Maybe this is one we want to explore even further. So it could be used to help form an investigation, but also just within the unit, just continually looking and revisiting your wondering wall to see if there's anything that you could address. Because sometimes they come from misconceptions you could address right there in the moment.
absolutely. And yeah, yesterday I was at a school, it was at McMullen Booth. I was in kindergarten, and they were launching their day-night unit, and they were watching the video. There was like a time-lapse video. So they were watching that, and the teacher gave everybody a sticky. And of course, they're kindergarten, so they weren't writing. A couple of them were trying to write some words, while we're just showing the pictures. So I was kind of managing the wondering wall. So as they came up, they told me what their wondering was. And it was really funny because they were very fixated. They weren't really looking at the day night. They were very wondered. They were very interested in the clouds. So they were wondering why the clouds, what makes the clouds move, or why they were. So that was kind of interesting. But it was really, really, really fun just to hear their thoughts on day and night, which was pretty awesome. And they had their wondering wall on like a door, so it was like a office door. They just kind of had a little, piece of paper back there, and they were sticking them on their door here. So that was a good idea. So that's a great where to start, is just getting a wondering wall up there. And like I said, are these all going to turn into an inquiry? Not necessarily, but it could be a great start for you guys, for sure. Thank you guys for adding some stuff. Was there anything in the chat, Wendy? Anybody put any
Um,
ideas or anything?
I did, let's see, I saw one, Charlena, if I pronounce your name wrong, I'm so sorry, but she said she has a wondering wall between her bulletin board and then her
Mm,
vocabulary. And
okay.
students revisit the wonderings throughout the unit to
Mm,
see if they can answer their own question. And if they have a theory, they share that with the whole class. So we're constantly wondering and thinking
yep.
about that. And it's a great way because, science conversations, our science lessons can take a left turn if we've got a great wondering. And I know
Right.
Jamie shared some of those examples. That one that he shared came from one of my students years ago at San Jose. we are teaching the water cycle, which fifth grade, you may be in that right now. But you know, if most of the water comes from the ocean, most of the water in the water cycle comes from the ocean, why isn't rain salty? And I'm like,
Oh
oh my
yeah.
gosh, that is such a great question, but I didn't want to derail my lesson.
Mhm.
So I had him write it on a sticky note and stick it up there. So it's great that we're having kids go back and look at, we don't just want to have it up in a bunch of stickies, but how are we using our wandering wall to continue the exploring our science concepts?
Yeah. And the cool thing about that, Wendy, is it can totally be turned into a project. It could do a free exploration. It can put some salt water in a cup, heat it up, and notice that the salt remains behind.
Mhm.
And the fresh water, they can even put a lid on there and collect the fresh water. Um, so that there you go. You can turn it right into
Mhm.
a actual inquiry. Yeah. And
Yeah, and
again, it
some,
might, yeah, and it could be a demonstration, so it might not even follow like systematic approach to it, you know.
I also had some teachers here in the chat say that they have a page or two in their science notebook, maybe at the very beginning or at the very end of the students collect wonderings and then going back and revisiting them as well.
Very cool.
Yeah.
Well, that brings me to the next slide. So keeping records. So how, man, great segue. Um, so how do we keep records? I love this part. It really gives some good ideas as far as that would be kind of the next phase. How are we going to record all these things? Like Wendy said, have a portion of your science notebook or have a project folder ready to go with some inquiry and some questions. That could be like the starting point. And then thinking about how they're going to turn that into possible inquiry. We do have templates as well, some different templates on Canvas. I'll talk about that in just a few minutes that are available that you could use as inquiry. We have like little journals and stuff that can be printed, or you can literally just put some notebook paper, construction paper, as you see right there. Fold a piece of construction paper, have some staples. There you go. There's your journal right there, and it's theirs, and it saves on printing and all that good stuff. And this is available K through 5, so even the primary, the little students can keep their own little personal small. I've seen it, little inquiry journals with just their little drawings if they were looking at birds on campus, and they're just doing like a daily log. So that's really all you need is just a place for them to record stuff. So kind of think about that as we move on. Um, how are you going to record and where are they going to keep their records of their inquiry? So there's a couple ideas. Any other ideas? So if you have something that you've done in the past, I know I'm working with a school. They're actually using the laid out project experiment boards that we used to have. There's a template of that on Canvas, kind of shows the different parts of the inquiry, and the kids are filling in those pieces as they go. So I know that is also available, but is there any other creative things that you've done? Anything in the past or any other ideas? Maybe you just thought of something really cool. If you would go ahead and put that in the chat for keeping records. That could be K through 5. I know sometimes in the primary grades it's a little harder, but we want them to be a part of the process. So we want them to be able to keep records, even if it's just little drawings of what they see outside, or if they're watching something happen, a demonstration, they can draw a picture absolutely of what's happening.
Yeah, in primary grades, they often have observation journals where they're
Yep.
maybe drawing a picture of their observations over time. Something
Yep.
else I've seen, I don't have any examples of it, but I know some teachers have moved to like a digital format in record keeping and the observations. They
Oh, yeah.
create something that's connected to their own Canvas page.
There were quite a few projects I saw last year that had a board and they had a QR code on them. And they would a person could come by and scan the QR code, and it took them to like a digital record keeping portion had like pictures and stuff on it. So that's an idea if you want to get into the fancy digital part, by creating a QR code, and then that will take you to a larger piece, a Canva or a book creator or something like that. Be totally cool.
Jessica also mentioned Adobe.
Oh yeah, Adobe's great for doing that. Yeah.
And I've
Cool.
also seen some schools, I know if you're in STEM club, if you've ever led a STEM club, I know Charmaine encouraged this, but also doing like a student recording and then attaching a QR code
Mhm.
to their boards, just for further information explanation.
Yeah, absolutely. And especially if you have a student that is doing it's if they're doing a engineering design piece and they're creating something and it's really large and brittle and may fall apart, it might not make it to the science showcase. Having a QR code that would take them to a movie. I saw that last year. A student had created something, um, and it was too big, too brittle to bring in. So they did a movie, and then when they did the QR code, it took them to that. It could take you to the movie on your phone. You get, oh wow, that's pretty cool. So that's something to think about as well. Because big bulky artifacts, we definitely don't want to um, get those to the showcase because they sometimes don't make it through the day, as we've seen in the past. So this next slide is really talking about opening things up. So getting started, here's what I want you to think about as well. So we've talked about wandering walls, we've talked about record keeping. Um, think about the investigations you might choose to do. So systematic investigations, that experiment is totally fine. But there's other types of investigations. There's some that are more fitting for certain grade levels, which we're going to talk about here. But it does support our standards, our benchmarks, because they do have to explain the difference between experiment and other types of investigations. So if we're just doing experiments all the time, that's not really going to get us where we need to go. Yes, it's going to cover a lot, um, but it's still not. It's going to miss the mark on other things, especially as we've seen SSA over the years and what type of questions they ask. They're asking not just questions about experiments. It's demonstrations. There's field studies. There's all sorts of stuff there. So there's a couple of bullets there. So maybe you are interested in doing some engineering design, where maybe they make the ramp, out of different materials and they make a prototype. That would be a whole better thing than watching a marble go down. Maybe they create the object that goes down the ramp. So they're actually building it. So there's different things there, some different ideas, models and research. So how does the water cycle work? How does the water cycle connect to our oceans? So they can create some sort of project for that, do a demonstration, which is not maybe following a systematic approach, but they have to provide some data and things like that. Field studies, so looking around your campus, what type of birds do we have around the campus? Weather patterns, so younger grades could talk about weather patterns and things like that. Take the temperature. Maybe you have a lot of plants on your campus and there's flowers, and the kids can count how many flowers are on campus. Or you can do something in the morning and something in the evening. How many squirrels do we see in the morning than the afternoon? So there's those different types of projects that we can engage in, as well. And that leads us into this one here. So you have our types of investigation. So as you're thinking, think about some of these different things. So you have your experiment, that's your controlled environment. This is where you're defining variables. You have an independent, dependent variable. You're making that change and you're collecting that data. So it's that cause and effect. You might have a research. We have people that they'll do research on a particular topic. Maybe, hey, what causes weathering erosion? So that could be a research project, or how does light energy work, or something like that. Engineering design, this is where they're solving a problem. So they're coming up with a solution. A lot of times they'll come up with a prototype, maybe a way to help clean the ocean. So they come up with some sort of device, some sort of tech. I always link the word technology to engineering design, because you're kind of come up with a technology to solve the problem with the prototype. And they test the prototype and come up with some data. The interesting thing with engineering design is that there's no ending to it, because then they can come back and then do a redesign. Okay, well, this worked, but this didn't work, so I did a redesign and tried it again. So there's no sort of formal ending in engineering design, because they're going to retest it maybe a couple times. Then you have your model or a simulation. Those kind of go interchangeably. So it could be like a model, like I said, of the water cycle, or a model of the solar system. Like here's a great one. I saw this one a few years ago. It was what is the solar system going to look like in 100 million years? And I was like, whoa, that's really cool. So they did a whole model of like the plants, what they might look like 100 million years from now. And they did a whole project on that. The last one is a field study. So this is a great one, and this could be done K through 5, where students are collecting data from around maybe the campus. This is great for the younger students because they're just using their observation skills. So they're counting maybe the squirrels or the birds or the clouds or different types of plants around campus, and they're really just maybe drawing or talking about those different pieces. So those are different types of investigation. So think about your class and your grade level. We're going to move into a little bit more specific on each one of these to kind of tighten it up. But these are the ones that you want to start thinking about. This is important because this is possible formats. So if I'm K1 and 2, if you're grade K1 and 2, you're going to be living down at the one project area. So that's like a class project. So if you're K1 and 2, you're doing a class board, you're doing a class project. The kids have little journals and they're doing little drawings. So it's kind of the same topic. So you're doing the same topic, whatever that is. How many birds do I see in the morning versus the afternoon? Or what type of flowers do we have on campus? Or how many squirrels do I see at lunchtime? Or something like that. So that's a one project, class project, and then small groups. So this is interesting, same topic, same variable. So you might do, for instance, paper airplanes. And does the mass of the paper airplane affect the distance it travels? So you could do small groups and everybody's doing the same project, collecting the same data, and then maybe they're comparing data. So this one is great if I'm a new teacher and I've never done this before. I might want to live in that area. If I'm like a third, fourth, or fifth grade teacher, I might want to live in that same topic. That's going to help you because you'll start to learn some of the processes, and it's very manageable. So you're able to manage materials and keep everybody on the same page. And the cool thing is, yeah, well, they're doing the same thing, but they want to share data, and that's part of the standards where they're sharing their data across groups. So that might be an option for you. The other option is same topic, different variable. So going back to let's stay on the paper airplane. So let's say I want to stay with that topic. But now each group maybe gets a different variable. So maybe one's changing the mass, maybe one's changing the wingspan, maybe one's changing the type of paper. So each group is getting a different topic to change. So they're collecting different data. Maybe one's seeing how far it will fly. Maybe one group is seeing how long it will stay in the air. So again, if I'm a new teacher, I'm probably going to stay in that road, and it does help with managing materials. The cool thing with that is it's different variables and all that good stuff. The next one up in the green is small group with partners. So this is like a big theme, and it's a lot more broad. So it might be energy is my topic, and then students might come up with something having to do with energy. And it could be a research, it could be a model. So they could be doing a model of how does a circuit work? Or they could be doing a research project on how circuits work or something like that. Or they could be doing an actual experiment on circuits. You know, does the amount of batteries affect how many light bulbs turn on or something like that? I'm just throwing that out there. So it's a lot more broad, but you can have a certain theme. Or even if you want to do weather or something like that, and all the projects kind of go with that. So that's if you're really feeling good and you've done this for a while, that would be a good place to be. And then you have your final one in the blue. That's like free choice. That's like um, it's free game. It could be go over to the Wondering Wall and pick one off the Wondering Wall, yeah, and turn it into a project possibly. That's free choice. That really opens it up if you're good at managing projects. You've done this a long time. Um, that might be good. Just remember this. I've walked into these rooms before, and the materials is the thing that could be the issue because you might have one group doing plants and one group doing stuff with circuits and one group doing something with something else. So, um, and a lot of times these are completed at home, maybe home and school with that particular group. Any questions about the formats? So hopefully that's helpful. It kind of gives you kind of a guide on, gee, where to why I want to go. As far as my comfort level, if you're looking at your comfort level when you first logged on, where you might want to stay. Other things to consider, you definitely want to think about materials. So if you're going to do a certain theme or whatever, think about the materials that you might need to get. If you're doing an engineering design, obviously you might need some materials for them to build something. We do have a P card, so if you need some sort of consumable pieces, every school does have science consumable funds available, $250. So just kind of get with um, your secretary, and they'll see how you can do that money. And we've sent out stuff. So there's lots of things that we've sent out over the years. We've sent out stem bins and different things that are probably available still on campus. And even some of the things we've sent in the past that you can totally use. Again, data journal. So we talked about that. How are they going to keep record? So think about how you're going to manage that piece. Evaluation. So on Canvas, we do have rubrics. So you could evaluate using the rubrics. We have K through 2 rubrics, and we also have 3, 4, 5 rubrics as well. That could help you with scoring that. If you want to come up with a personalized rubric, I definitely encourage you to use Magic School AI. There's a rubric agent, and you can put in specific things and specific points for a rubric if you want to go that route. That's a great resource to do for that as well. But we do have some rubrics that we provide for that. Pacing. So again, pacing is a big one. Like you want to make sure that the project can be done within a time frame. If I'm going to do something on plants, it takes a while. You have to grow the plants. You have to get materials. If you're going to grow them, it takes a couple of weeks. I like to steer people toward physical science because it's quick. You can collect data very quickly with physical science things. If you're taking temperature or doing mass and motion and all that good stuff, it's quick data collection. There's some earth science things, obviously, that are very speedy as well. So just think about your pacing as you get into that. And we'll talk a little bit more of that. I got some ideas. And then student grouping, like how are you going to group students? Are they going to do individual, partners, triads? I try to not go above 3 in a group because what happens is a lot of people, you'll get the students that don't participate as much. So I think 3 students is a great number if you're going to do groups, because it helps kind of split up the jobs and stuff like that for sure. Wendy, anything in the chat? Any comments about formats, investigations, things to consider this
No,
portion?
people have just been sharing ideas about field
Perfect.
studies, observing lizards, birds, squirrels.
Yeah,
Larissa, says she had fun doing, germination rate on various bean seeds in 3rd grade.
perfect.
Just know that if you're doing something like that, which is great, just
Yeah.
consider how much time you would need to do.
That's
Some of
yeah.
our experiments are quick right there. Others you need to plan ahead of time. But think about how you can link it to what you're already teaching or what you have taught. Maybe pull something from, from something you've already covered. It'll help with review.
That's a good point, Wendy, especially 3rd grade if they do a lot of plants and life science. So if they're doing the project as they're
Mhm.
learning about plant structures, that's very perfect.
Yeah.
Um, even 5th grade, they're doing weather right now, so they literally can do a project on climates, environments, and stuff like that, temperatures and things like that. Yeah. This next part is speaking to our timeline. So we do actually have pieces embedded in our timeline, some chunks of time for this. We want to give people opportunity to do these things within the time frame. So 3rd grade, there is a project time that is right there. So science projects. Now you could move these around, like wow, that's really early. Say they are movable, um, but we wanted to at least gift that time of projects for 12 days. Even if you just get a nice start there, that's totally fine, and get a good strong head start. It's totally cool. So that's 3rd grade. 4th grade, we have a little bit of time there from February to March to also work on the projects as well, or get started. 5th grade, though, there's not a designated time frame for science projects. We have the mock SSA in there, and we also have review lessons because we want to stop things. We want to get through everything in time for mock SSA and also time for review. So we put teacher discretion on that one. Obviously, we want 5th grade. I think it's a great review for SSA because we are tested on nature of science, but there is not a designated time block in there. I will show something in just a minute, an idea, and I actually have a couple of schools that are actually doing that this year. I'll share with that in just a minute. That might help with 5th grade. But K through 2, so the cool thing with kindergarten 1 and 2, they have science units right before their dedicated science project time. So you'll see on the timeline, they do a whole lesson on a specific thing. So like 1st grade, they get a whole citizen science field study lesson. So they're learning how to do field studies. They're learning how to make observations and keep records and all that good stuff right before the project. So that whole piece is going to give you a lot of good ideas. It's going to generate, there's already ideas embedded in that unit. And you can take one of those ideas and run with it for the field study. So kind of cool. You got a nice unit to learn about it. And then boom, there's your project time. So look a little closely here. So K1 and 2, kindergarten, first grade will focus on field studies. That is really the best for K1 and 2. They're not really ready for identifying variables and controls and hypothesis and all that stuff. We want them to use their senses, and we want them to record things that they see. It was interesting with the Wondering Wall with kindergarten the other day. A lot of kids were writing down things that weren't even in the video. Girl was drawing a house. I'm like, there wasn't even a house in the video. So getting students to record actually what they see without adding, um, they drew a sun with a smiley face. Well, was there really a smiley face? So getting them to do that and understand. So things that they can observe with their class, what they have on campus, so birds, gardens, butterflies, squirrels. Again, like I said, there's a whole unit that they learn about that before they get into it. So we really want them to do things on field studies. And here's a nice little board. So this is actually from Dunedin a few years ago. So their question was, what types of birds are on our school campus? That's it. So they took they had binoculars. So there's pictures of the kids with binoculars. They had some bird guides. So they just did their whole project field study on types of birds they found around their campus. Beautiful board. And all the kids had little journals, their own little journals. There's a couple pieces of paper, and they would draw the birds that they saw around on school campus. Then the teacher just pretty much just typed up the elements, the different elements, and posted it on a board. Grade 2. So grade 2 can also do a field study, but their unit is going to revolve around a engineering design. So they're actually going to do a little project there on creating something and then using that to solve a problem. So you can stick with that, but if you want to do engineering design, that's totally cool. They could also do one thing we have on campus. So we do have an experiment part, but we've actually kind of brought that down a level. We took some of the elements out, so it's very doable for second grade. So they have a whole unit on engineering design coming up, and then you can see when their project piece is. Here's the other option. This is what I have other schools. I have a couple of schools that are doing this. Some schools have actually mapped out and designated a day or two during the year to work on the projects. For example, obviously August, September are already gone. But if you started this in October, you can create investigation questions for wondering. So you have your wondering wall, and then have those turned into questions that could drive inquiry. Determine your types of investigations. Like, okay, we're going to stick to field study, guys. We're going to do a field study. And then November, you would work on investigation elements. So you're maybe setting up the project. What are we going to do? What materials are we going to use? All that good stuff. December, we're still working on those setup pieces, but we're getting toward where we want to be ready to carry out any type of investigation, whether if I'm doing a field study or if I'm doing engineering design or if I'm doing an experiment or a model demonstration. I'm ready to go in December. January, you actually perform the investigation. So you're going to collect data, evidence, charts, all that good stuff, depending on what your question is. February, you can analyze the data and create some visuals, charts, graphs, representations. March, you work on the investigation elements. So this would be the post data collection. So anything having to do with the results or conclusions, any sort of write-ups that look at data would be maybe in March. And then April, we publish. We publish our investigation, whatever it is. If it's our field study, if it's our engineering design, we're typing those up. If we're going to do it digitally, if we're going to create QR codes, all that is ready to go. So you're going to choose and create your display methods. And then May, we have our showcase. A lot of schools do have a school showcase, so they can have that going on as well. So those are some different options that we have on our timeline, but this would be another option that you could do. A lot of times people do in the past, they kind of wait till right before showcase. That does add a lot of stress and stuff and testing and all that good stuff's going on. So we try to recommend people don't wait till the very 2 weeks before showcase for that.
Jamie, I just want to give you an 8-minute warning.
Oh, okay. Wow. And you didn't think I was gonna have it. I can put this in the chat. I have this. So this is something you could do with your staff, or if you like this PowerPoint, I can put this PowerPoint on campus at each of the grade levels. If you wanted to bring this back to your school and maybe train up your teachers, that would be totally awesome. Actually, we encourage that. But I can put this little, this is like a card sort. So these are different questions that could be an investigation. So what type of investigation could they be? But let me go ahead and put that in the chat. So you have this document.
So as Jamie's putting that in the chat, this is a great sort to talk about. Are these ones that would be right to do an investigation, a systematic investigation? Would it be a field study? Or maybe it's in engineer design, or maybe it's just research. It's a question that you can, that the answers are already published and you can research and learn more about something that is of interest to you.
Okay. I'm not seeing, I might have to wait till the end because I'm not seeing the attachment button on the
I wonder,
plus.
Jamie, if we could also email it to all of them through the PLN
I can do
email.
that. I'll do that because I'll save time. Cool. So we can do that too. So the timeline, as far as the engineering showcase is concerned, so the timeline for that, how things happen. So in January, we actually send out a general letter. Wendy will share that with the school admins. A letter of intent. We need to know like, hey, what schools are going to participate because we have to do a count. We have it at the St. Pete College and Clearwater campus, so we need to know like how many projects to expect because we assign them to rooms. We need to know how much materials to order, how many books to print, how many t-shirts to order. So this is a very important form that gets sent out. And on the form, it'll say, yes, our school is going to participate, even in a showcase and school showcase. No, we're not going to participate, or maybe we're not going to have a school showcase, but we're going to send projects. And throughout the years, I've had whole schools participate, but also I've had just grade levels at schools participate. Maybe just the fifth grade person participated, or kindergarten or second grade. So there's not any one way to do this, but we just need to know school's intent there. Then in February, we send out a showcase packet. Once we get that form, letter of intent, and these are all in forms, which is very nice. We've gone digital, which is yay, awesome. So we send out our showcase packet that has all sorts of information, rules, and all that good stuff for the showcase. In April, we start getting submissions. So this is like once the school has said, hey, we're going to send these projects to the showcase, I would get those forms, those registration forms, so we can number and put those in the rooms. Also, volunteer registration. We need volunteers. So if Wendy has her thumbs up, yes, this does not run without volunteers. So we need volunteers. So if you're interested, it is a Saturday, um, but it is a fun day. It's 10 to 2. There's all sorts of things going on. And you get to really see, you get to talk to families, you get to see all Pinellas County doing all sorts of fun things. So that is a really great thing. So, and when the volunteer registration form comes out, please consider doing that. We do feed you, and we do provide, is a $50 gift certificate from Wendy's for materials, right?
It's if you work all day, it's 50. If you work half
Yes.
day, it's 25. And what we do is we put money into your school account and we let your
Mhm.
secretary know that that money is for you to spend on science materials.
Yeah. So yes, we would appreciate that. And then early May projects are ready to deliver to St. Pete College. Um, these are a couple of our ideas. So schools can submit up to 6 projects ranging from K-5. So they don't all have to come from upper grades. We get lots of great K1 and 2 projects. Projects are not judged. So they're not judged at the showcase, nor do our students expected to present their project. They don't have to stand next to their project and do any presentation. This is like a showcase. Students do receive a t-shirt. So if they come to the showcase and their board is on display, they get a cool t-shirt. And then throughout the day, there's activities, scavenger hunt, building challenges, games, robotics, animals, interactives. We have middle and high school. They bring their robots. They have a big robot battlefield. And then students can take their showcase journal to the prize room. It's like Celebration Station in there. There's all sorts of prizes, and they can get all sorts of cheap pieces of plastic that break in seconds, but kids love them. It doesn't matter. It could be a sticker, and they think it's the greatest thing in the world. But it's a lot of fun. It is exhausting and very fun. And those are just some of the pictures from last year. So there's all sorts of interactive things going on, building challenges, and then obviously the projects are all around the campus as well. And then on Canvas Resource Center, so every grade level has this button. I highly encourage you to go to that button, the showcase button. Within this button, you will see it's all broken down for you. There's some general information. There's like a project guide. There's some one pager. So if you're like, I don't understand what a field study is, the one pager will explain to you what a field study is. There's examples and question examples. There's different templates. So if you wanted to do a specific journal, there's journal templates there. There's also, like I said, the rubrics are available as well. And there's also science, but hey, I don't know how to put my science board together. Well, guess what? There's science board configurations on Canvas. So you can go there and start looking at those resources and even download any of those resources to get started for sure. And the big thing is, so in the chat, before we wrap things up here, what's your first steps? So we got a lot of information. This is an hour. Sometimes they'll do a 3-hour training. But this was 1 hour to hopefully spark your drive toward doing this, doing a project. So what are you going to do? What are you going to do? What's your beginning step? If you want to drop that in the chat real quick, some ideas. What are you going to do maybe you're going to start with a wondering wall. Maybe that's where we're going to start.
That's the first thing that popped in, wondering wall. Identify in my area where it will be in my room.
Uh-huh.
I love that this is where everyone's going because we want, again, like you said, these experiments or investigations to come from natural wonderings.
Mhm.
That'll really get the kids hooked.
And then remember, choosing appropriate project types. So if I'm in first grade, I might stay away from an experiment because kids don't need to get to that systematic approach yet. They need to be able to use their senses and record ideas and all sorts of stuff there. Um, I thank you guys very much. There is a QR code for the training, a little survey.
And I
And
also
then-
put the direct link in the chat, Jamie.
Yes. And do you want them to put if they need a trade in the chat? Okay. So if you're doing trade day, put trade day in the trade day in the chat. Other than that, you will get a stipend. So if you want specifically a trade day, that's fine. And please reach out to us. So if you're stuck, if you're like, I'm not sure, um, even if you're I had a lot of primary teachers ask me last year, and this, hey, would this be a good project? Oh yeah, that would be great to help guide you. So please email myself or Wendy if you need some support. We can totally help you. We don't want you to shy away from this or be overwhelmed. We want this to be a great experience because it's a lot of fun. And if if it's managed well, it can be really awesome. And it is great for kids. It's student experience, but are also learning some very valuable skills. So I thank you guys very much. Once you've done your survey, you are free to go. Thank you for joining us. So many people on here tonight. Thank you.
Jamie, you have a question
Yeah.
about Big Idea 8 for fourth grade. When will it be on Canvas?
It is on Canvas.
That's what I thought. Okay.
Yeah. I just need to finish up the assessment, but everything is ready to go.
Okay. And again, some of you did put stipend and that's fine, but again, if you want trade, put trade. And if you don't put anything, we'll just mark you for stipend.
Thank you guys. I appreciate it.